Why We Die by Venki Ramakrishnan. Audiobook summary and review by StoryShots. Your cells have been executing your death sentence since birth. Introduction. Aging isn't decay. It's a coordinated biological program your cells run with ruthless precision. That is the thesis of Why We Die, the new science of aging and the quest for immortality, by Venki Ramakrishnan, Nobel Prize-winning biologist and former president of the Royal Society. Your cells choose death over chaos. Your body replaces billions of cells every day, but each division shortens a protective cap called a telomere at the end of every chromosome. After about 50 divisions, the cap vanishes and the cell stops replicating. This isn't a flaw, it's a feature. Cells that ignore the limit and keep dividing indefinitely are called cancer. Your body trades immortality for control. Every supplement promising to reverse aging at the cellular level is selling fantasy unless it can solve this trade-off. We are not programmed to live forever. We are programmed to reproduce and then get out of the way. Knowing your cells have built-in limits means nothing if you misunderstand what actually wears them out. The real reason your cells break down. Your mitochondria leak. Every time they convert food into energy, they release reactive oxygen molecules that damage DNA. This happens billions of times per second in your body. Your cells have repair systems. When you're young, repair outpaces damage. Around age 30, the balance shifts. Damage accumulates faster than your cells can fix it. The only intervention proven to slow this across species? Restricting calories. When your body senses scarcity, it shifts resources from growth to maintenance. Aging is not one thing going wrong. It is everything going wrong at once, slowly. If this changed how you think about aging, someone in your life probably needs to hear it too. We might eliminate aging before we understand it. We already have organisms that don't age. Hydras regenerate indefinitely. Naked mole rats live 10 times longer than mice their size without cancer. Bowhead whales live over 200 years with DNA repair systems, far more effective than ours. The scientific race isn't to decode every mechanism, it's to engineer the interventions that work. CRISPR gene editing can already insert longevity genes from one species into another. Senolytics, drugs that selectively kill aged cells, reverse physical decline in mice. Young blood transfusions restore cognitive function in old mice. Even if we extend lifespan to 150 years, we haven't solved the problem. We've only delayed it. True immortality requires either preventing all cellular damage or achieving perfect repair. Both are currently impossible. Eliminate senescent cells too aggressively, and you might trigger cancer. The question is not whether we will extend human lifespan. The question is whether we will extend health span along with it. Final summary. This summary of Why We Die by Ramakrishnan connects three truths. Your cells self-destruct by design to prevent cancer, damage accumulates faster than repair after 30, and we might engineer longevity before understanding its full consequences. The full book explores why evolution doesn't care if you live past reproduction. How the immune system turns against you with age. What happens to consciousness if we achieve biological immortality, and why the real breakthrough won't be adding years to life, but adding life to years. We're putting together the full summary of Why We Die right now, with a visual infographic and animated video. Follow the book in the StoryShots app to get it the moment it's ready.